Hello and welcome. My name is Dario Schulz, and in this video I'm going to present some preliminary empirical evidence on the impact of providing digital information to smallholder farmers. In developing countries, the low productivity of many smallholder farmers has been linked to both market failures, but also a lack of information about good agricultural practices and technologies. Information and communication technologies can enable the transfer of information in order to provide inputs, e-commerce, or also digital advisory services to remotely located farmers. Over the last 10 years, as you can see on the right-hand side, there has been a strong increase in the number of agricultural services that has emerged. And as the map also shows, this occurred primarily in developing countries. Even though there is a large number of agricultural services, the evidence that these services have any impact on the actual farmers and farming decisions is still very limited. I present here a theory of change, which initially assumed that there is a lack of information and that the provision of information would then increase the knowledge farmers have about technologies and practices, which then in return affects their decision to adopt certain practices in a timely manner. And in return then leads to higher yields, lower yield losses, or also changes in production costs, which then finally amounts to a change in the net income of farmers. And in order to provide or to study the impact that the provision of information has, we can conduct a randomized controlled trial in which we randomly assign farmers to either receive or not receive certain informations, and then measure the different outcomes. So in order to do this, we looked at two contexts. The first one is in El Salvador, where the local partner NGO has been working for a couple of years with farmers that engage in year-round vegetable production and receive regular physical extension visits by this NGO. As you can see here on the right-hand side, there was an initial push message informing about the opportunity to receive further information about, for example, in this case, a certain pest. And then if the farmer responded to the message, he would receive some multimedia content. This could be an image, an audio, or video to inform about the pest and also how to treat it in the recommended manner. The advantage of using WhatsApp was that we can actually see whether a farmer not only received, but also read a message and whether he or she responded in order to get actually the multimedia content. So we can actually look at a local average treatment effect, not only on the intention to treat. In Haiti, the study context is slightly different. The local partner NGO has been working there for already more than 7 years and trained more than 5,000 farmers in group trainings, and also provided physical extension visits on a seasonal basis to a couple of hundreds farmers per season. But the baseline data in this context was very limited. In Haiti, because of the large number of farmers and also the large study area, we were actually able to randomize not on the individual farmer level, but on the village level. So we used a cluster randomization and assigned villages with all their farmers respectively to control or treatment groups, so to either receive or not receive the SMS with good agricultural practices. Now I'm going to show some results. So on the left-hand side, you can see the estimated impacts on knowledge in El Salvador, where you can see there were in total 9 knowledge questions that were also aggregated into a knowledge score. And that knowledge score is significantly different from 0. We see a quite large effect of between 0.4 and 0.5 standard deviations caused by the WhatsApp intervention. On the right-hand side, we can see a more heterogeneous picture. We can see that there seems to be a small positive impact of the intervention on most of the outcomes. However, most of these impacts remain statistically undistinguishable from 0. And we can also see that the overall magnitude is much smaller with only a 0.1 standard deviation effect size. So what this shows is that even though we are still lacking precision in these estimates, there seems to be evidence that the provision of digital information does cause an increase in the knowledge about certain practices and technologies, and also that the knowledge about these technologies and practices induces increased adoption of these practices. So to summarize the results, I would like to highlight that with increasing network coverage, information and communication technologies are becoming a more and more cost-efficient tool to disseminate information, also towards remotely relocated farmers. Although our results lack precision, there are likely positive impacts via both SMS and multimedia content on knowledge gains induced by the provision of digital information, which then also likely translate to a slight increase in the recommended practice adoption. There were, however, deviations from the pre-registered study design, which have to do with the complex field reality and also with the remotely manner in which the whole study was conducted. This may have been the reason for the imprecise effect estimates. What remains to be considered in the future is certainly the digital divide. So to what extent farmers that already possess access to information and communication technologies may then receive additional information and actually gain more from this information than farmers that do not have access to these technologies and therefore become potentially more and more marginalized. For the future, it remains interesting to look at more personalized advice. So for example, to include remote sensing data and crop modeling approaches in combination with machine learning or artificial intelligence in order to derive more site-specific management recommendations to also remotely located farmers. And with that, I would like to thank you for your attention.